Hello everyone, welcome to my channel. In this video, I'll explain an example on Y parameters. Find short circuit admittance parameters for the circuit shown in figure. We have admittances given YA, YB and YC. Let us write the main equations first. I1 equal to Y11 V1 plus Y12 V2. I2 equal to Y21 V1 plus Y22 V2. To find y11 and y21, v2 should be equal to 0. You can observe from the main equations here. To find y11 equal to, from first equation you can see I1 by V1 when V2 equal to 0, and y21 equal to I2 divided by V1 when V2 equal to 0. Whereas to find y12 and y22, V1 must be equal to 0. From equation 1 you can see y12 equal to I1 divided by V2 when V1 equal to 0, y22 equal to I2 divided by V2 when V1 equal to 0. Let us start with finding first y11 and y21. To find y11, V2 equal to 0, y11 equal to I1 by V1 when V2 equal to 0, y21 equal to I2 by V1 when V2 equal to 0. Let us redraw the circuit. This is I1, V1, YA, YB, YC. This is I2. And the condition here is V2 equal to 0. So we should short circuit this terminals, port 22 dash or BB dash, V2 equal to 0. If we short circuit, then the equivalent resistance of these two will become 0. So we can redraw this figure like this is how the circuit will become. Let us find here Y equivalent. Y equivalent equal to YA plus YB. If two admittances are in parallel, equivalent admittance is the sum of these two admittances. So Y equivalent equal to YA plus YB. I can write here according to Ohm's law, V1 equal to I1 into R equivalent, or R equivalent we can write Z equivalent, I1 into Z equivalent. So V1 equal to I1 into Z equivalent. So Z equivalent can be written as 1 by Y equivalent. So I1 by V1 equal to Y equivalent, which is equal to YA plus YB. Y11 equal to I1 by V1 when V2 equal to 0. So Y11 equal to YA plus YB, mho. Units of admittance is mho. Coming to the next part, Y21 equal to I2 by V1 when V2 equal to 0. Here, according to nodal analysis, if you see here, the voltage here will be nothing but V1, and we can write here, and this is always I2, and we can write here I2 can be written as minus V1 into YB. See here, this is I'm applying nodal analysis. The voltage across this point can be V1 because while applying nodal analysis, we consider one node as reference node. So this can be considered as reference node, which is a ground point. And whenever you see this point, obviously this the voltage at this node will be equal to V1. So we can take it as a V1. And the voltage across here, or the current flowing in this admittance, can be written as I2 equal to V1 into YB. And this is I2 is flowing in reverse direction with respect to I1, so we can write I2 equal to minus V1 into YB. And if you rearrange this, I2 by V1, if you rearrange this, I2 by V1 equal to minus YB mo. So Y21 equal to minus YB mo. Next, to find Y12 and Y22, V1 should be 0. Equations will be Y22 equal to I2 by V2 when V1 equal to 0, and P12 equal to I1 by V2 when V1 equal to 0. By redrawing the circuit, I1, V1 equal to 0 means this becomes short circuited, V1 equal to 0, and we have I2 here, and this is V2, and this is YB, YC, YA. When V1 becomes short circuited, the circuit will becomes like this. This is YB, YC, okay. So we can write here V2 equal to I2 into Z equivalent, or you can write I2 divided by Y equivalent, since impedance is equal to 1 by admittance. And you can write here I2 divided by V2 by rearranging the above equation, by making this to come left hand side and this to right hand side. We can write this as Y equivalent. And according to the circuit, YB and YB and YC are in parallel. You can see if current flows here, it gets divided in these two branches. So we can say that YB and YC are in parallel, and Y equivalent can be written as YB plus YC. Therefore, Y22 equal to I2 by V2, which is equal to YB plus YC mho. Units of admittance is mho. And to find Y12, I1 divided by V2. By considering nodal analysis here, you can see node is a common point where two or more elements are connected. You can take this as node point and this as node point. This node point is usually considered as reference node, or you can take it as ground point. And if you take a node point here, the voltage across here will be the same voltage appearing here, V2. So you can write here the current flowing in this YB can be written as I1 equal to minus V2 into YB, because this is admittance. So you can write I1 equal to minus V2 into YB. So I1 by V2 equal to minus YB. By substituting this here, you can write Y12 equal to minus YB more. So we have got all four values. Let us write all the four values here. Y11 equal to, we got Ya plus Yb more, and Y12 equal to minus Yb more, Y12, okay, Y21 equal to minus Yb more, and Y22 equal to Yb plus Yc. So the Y parameters for this network are these four parameters, and you can write the main equations as I1 equal to Y11 I1. In place of Y11 you can substitute the value you got. This is V1 plus Y12 V2. Okay, next I2 equal to Y21 V1 plus Y22 V2. By substituting the values which you obtain, you can write the Y parameter equations like this. That's all for this video. Thank you.